Physics, Chapter 1, Physical Quantities and Measurements. Lesson 10, Period, Frequency and Oscillation. Now, in this video, I will try to help you learn and understand these three new terms and concepts in physics: period, frequency and oscillation. These new three terms itself are terms which we often encounter when we study motion which repeat itself. Okay, so let's have a look at the next slide here. Right, many things around us move in a manner that repeats itself. One example is a stand fan that you find at home. So another example that we can look at will be the aircon outlets and even the frequency of bars 952 and so on. This motion which repeats itself, in science we recognize that and we call that periodic motion. In the next slide, let's explore a little bit more what these three terms mean. Okay, we'll start off by oscillation. Okay, and oscillation can be understood as this motion whereby, for example, if you look at the stand fan, if the stand fan is switched on and it starts to move from the left to the extreme right and back to the left again, this motion from one end to the other and back again to the starting point, this is known as one full oscillation. Okay, so if you ask me, can I consider one full oscillation if the fan were to start from the right hand side to the left and back to the right? Yes, indeed, you can consider that as one full oscillation. So how about from just left to right? How many oscillations is that? If it's just simply from left to right, we consider this to be half an oscillation. Okay. Next, let's have a look at period. Okay, period is simply defined as the time for one full oscillation to happen. So if you take the time, measure the time for the fan to move from left to right and back to the left again, and if it takes 3 seconds, then we say that this 3 seconds is known as the period of this stand fan. Frequency. Frequency is defined as a number of complete oscillations in 1 second. Right, for frequency, we will deal with this a little bit later in later slides. So what we are going to do right now is to understand a little bit more about oscillation and period itself. Okay. Now in science, it is usually more convenient to use the pendulum to study repeated motion rather than just a stand fan. Okay. Now, so what is a pendulum? A pendulum is simply a very simple device, okay, where we suspend a heavy load at the end of a string, and we fix the string to some fixture, and once we displace the load to one end, let's say we displace the load to A and released, this load itself will swing repeatedly from A to B to C and back to A again. Alright, so this is what we call a pendulum. This heavy load, we often call that a bob. So if we were to look at this diagram and we were to displace the bob to say position C and release it, we know for a fact that this bob will swing from C to B and from B to A, back to B and back to C again. This movement, okay, is known as an oscillation. So try not to confuse this with the period itself. The period of an oscillation refers to the time taken to make one full complete oscillation. In physics, period has a symbol capital T, and try guessing what the SI unit is for period. Well, since period is basically a time, so SI unit for period is therefore seconds itself. Now, let's have a look at frequency. Frequency, again, let us recall, it is defined as the number of complete oscillations in 1 second. The symbol for frequency is a small letter f. And the SI unit of frequency is this unit called Hertz. H-E-R-T-Z, and it has a symbol capital H and a Z or a Z. Okay. Now frequency itself. Okay. Let's look at this example to understand a little bit better what frequency means. If I have a bob which has been displaced to position R and it was released, this bob, you know jolly well, will swing towards S and then back again. So let's assume that this particular bob, once it's released, it is able to make 3 complete oscillations in a time of 1 second. So if that's the case, we can say that this bob has a frequency of 3 Hertz. Now let's have a look at another case. What happens if this bob makes 10 oscillations in 5 seconds? What is therefore the frequency of this particular pendulum? Now let's recall again. Frequency is defined as a number of complete oscillations in 1 second. So since there are 10 oscillations made in 5 seconds, by simply dividing 10 with 5, that tells us that this particular pendulum will be able to make 2 complete oscillations in 1 second. Therefore, the frequency of this bob will be, or this pendulum will be, simply 2 Hz. Okay? Right. At this point, I'd like to introduce an equation that relates the frequency to the period of the pendulum. Okay? It looks like this. Small f representing frequency is equal to 1 over the period of the oscillation. Okay, so try to remember this equation. Now, let's have a look at how we can make use of the ideas of period, oscillation, frequency, and as well as the equation to deal with some common problems. Okay. Now, a pendulum takes 0.8 seconds to move from R to S. What is therefore the period of the pendulum? Now, let's recall, one complete oscillation would mean that the bob will move from R to S and back to R again. If 0.8 seconds is the time for it to move from simply R to S, this motion itself is half an oscillation. So for one complete oscillation, that would mean that the pendulum will take a time of 1.6 seconds. Okay, so that is the period of the pendulum. Now, after we have obtained the period of this pendulum, we can actually calculate the frequency of the pendulum itself. And the equation is none other than F equals to 1 over capital T. So once we have this equation written out, what we will need to do is simply to put 1 divided by the period that we have obtained in part A. And using a calculator, we should find that the frequency of this particular pendulum is simply 0.625 Hz. How do we interpret this? This simply means that for this pendulum, it's able to make 0.625 complete oscillation in 1 second. Okay, let's have a look at work example 2. Now for this particular example, the information given to us is a little bit different from example 1. Instead of giving us the time taken for half an oscillation, this information is given. It says that the pendulum has a frequency of 4 Hz. So what does that mean? Well, recalling back the definition of frequency, we can say that, hey, this particular pendulum is able to make 4 complete oscillations in a time of 1 second. So therefore, how do you calculate the period? Well, in this sense, in this particular case, we can actually call on the equation again. And the equation is simply this. By writing this down, by manipulating this, we are able to get period is simply equals to 1 over frequency. Okay. And since we have the information regarding the frequency, we just substitute the small f with 4 Hz using a calculator. That will give us a period of 0.250 seconds. Okay. For part B, what would therefore be the time taken for the pendulum to move from simply R to S? Again, let's recall, from R to S is simply half an oscillation. So since the time for one, or the period for one full oscillation is 0.25, the time taken for it to make half an oscillation is simply taking this number and dividing this by 2. So the time taken is none other than 0.125 seconds. Now this is the last slide for this video. So before we end the video itself, let us quickly do a quick summary of what we have learned on this video itself. There are 3 concepts that we have dealt with today with regards to repeated or periodic motion. These 3 concepts are oscillation, period, and frequency. Remember that period is defined as a time taken for one complete oscillation and is measured in the unit seconds. Frequency is defined as the number of complete oscillation in 1 second, and it has a symbol small f, and the SI unit for frequency is Hertz. Capital H Z is the symbol for frequency. And lastly, the equation that links both frequency and period is simply given by this equation. F is equals to 1 over T. We can also manipulate that to give us capital T period equals to 1 over F. You will need to remember this equation. With that, thank you so much for listening.